So now we've been looking at the push-pull mechanics of Git, but one of the things I have mentioned but not really gone into is the branching. So if we're looking at GitHub here, you'll see that there's this button named branch and it says master, and you can pull it down, you see there's only one branch. And what does a branch actually mean? Well, one of the things I would like to show you is an idea by Vincent Driesen. This is a blog post of his, very famous. So here he's talking about branches, like this is the master branch. This is the same branch as we have here in Git, right? But as you're developing software, you always want the master branch to be clean, right? So the master branch should always contain software that is the best that you can provide. But you need to develop on this software. And of course, if you have the software locally on your machine, nobody is able to see it until you push to the master. But if you're going to develop with other people and you're going to use GitHub to share that data, then you need to have a branch. And Vincent Driesen here uses the development idea that you should have a development branch. So you'll branch out and you'll do a lot of development here in the development branch. And as you come up with ideas for features, you'll make individual feature branches, that consist of commits, as we saw before, that we had several commits to get to where we are now. So the idea here is that we come up with a feature and we do some development there, and then we merge back. So that's one of the new words that you can merge and Git. You can take this branch, you can merge it back into the development branch, and you also saw one feature here that really, got lost, and then eventually further along it gets merged. But these features here are branches in themselves, and when they're merged back into the development, then this point here has all the development that was going on in this part and in that part. So all the changes are combined here. At this point, you might think, okay, this seems like a good release candidate for our software. So we'll put it into the release branch and we'll start the releasing. And here we're not going to add extra features. We're only going to test everything with all the tests that we have and see if it works, and says only bug fixes here. So you're only fixing all the bugs that they introduced while developing. And once you actually got to a point where it says, this seems like a really good product, it's tested, let's release it to the main branch. And you go here and then you tag it with 1.0. Up here it was 0.1. And as you can see, we also have a 0.2, because sometimes you actually have production software and you figure out, oh, there's a bug. So you have what we call a hot fix. So you create a branch and you hot fix this one as fast as you can. And once the tests are good, you'll release it. So you can see this is a bit complex. It's much more complex as you would use as a starter programmer, but it's just nice to know that you can use branches for this. So basically, as a starting programmer, you probably want to have a master branch and then have a 1 or 2 feature branches for the things that you're developing together with your mates. So let's see how we can make a feature branch. So going back to our Hello World program, let's imagine that we want to, change this world to the name of the user that is going to use the program. So basically, we want the user to input his name, so we need to include the string type, and then we'll ask std cout what's your name, ? And then let's not put in something extra there, and then we'll use std cin. So instead of cout, we get cin, and we input that into a name variable. But of course we need to initialize that name variable, string name. There we are. So we put in the name there, and then we need to output that name. There we are. So it says it's going to say hello and then the name. Okay, so this seems all good. Let's save that and build it. So we'll pull up our terminal here. cd catkin workspace catkin build. There we are. We'll source our devel setup bash, then ROS run hello, and it says what's your name? My name is Carl, and it says hello Carl. So this is all good. There might be improvements. Maybe we should say what is your name in order to be more formal, or maybe that we need a space here and so on. But let's imagine that I didn't see this right off the bat. Maybe I want to put this onto GitHub and see if there's other programmers that I'm working with that will fix these things. So instead of polluting, or let's call it polluting, the master branch, let's make a feature branch that will have this unfinished code in it, right? So as you can see here, we haven't added the hello CPP, so the modifications that we've done here, you can see the green parts here are not a part of the thing that is in master right now. So let's make another branch, and we call it feature name. And then we can add that. You can see now it says feature name down here. If we go up here, cd into the source, then git branch shows you that by this asterisk that now we're on this branch where before we were on the master branch. So we'll add this to the new feature branch and ask for name, right? And we'll commit this. And now the thing is, we can So if we look at our repository here, the hello package, right? There's still only one master branch because we didn't push the other branch. And remember, when we pushed the master branch the first time, we had to note that we wanted to push upstream. So we'll go git push upstream to origin our feature name, right? There we are. And if we go and look here, it says now the feature name is here. And if we look in the if we look in the source code, we'll see that we've changed some things here. But if we go and look in the master branch, it's still the same old stable version that we had before. So now another person could go and clone this and work with us on this feature. Yeah. When we think this feature is done, we can merge it back into our master branch. So we do that by checking out the master branch. So git branch shows us that we are on this feature branch, but we want to be on the master branch in order to pull in the changes that we did in the feature name. So we'll say git check out master. So now you see, now we're on the master branch. We'll say git merge the feature name. There we are. And as you can see, we did change to 6. We added 6 lines to the hello CPP and we deleted 1. And now if we go here and have a look here, we see we're on the master branch and we have the changes in the master branch now. And we can also kind of visualize this in our git k that the feature name branch and the master branch is the same, but we haven't pushed the master to the remote, right? The feature name branch is still on the origin, but we haven't pushed the master part. So we'll just do that in order to keep everything nice and tidy. So git push. Yeah, that should be enough. Oh. There we are. So now if we go and look, then the two things should be the same. Whoops. See, there's 4 commits on the master branch, also including ask for name. So this special GitHub methodology, or sorry, just Git methodology of using these branches actually uses the Git flow, if you read through this, you'll see that you can do all this with standard Git comments like git checkout, git merge, blah, 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 blah. But there's also a tool called Git flow that you can use. And if you go onto, I think I had this here, if you go on to NVIE, that's Vincent Driesen, that's the guy who wrote this blog post. If you go onto his GitHub, you'll see with Git flow, there's an added Git tool, and there's also some introductions like this blog post and these here about how to use Git flow. So if you think that this is a good idea, definitely go and check out these blog posts. Another way that we could use branches is for ROS, the people detection. This is just an example. The people detection repository has a lot of branches, but it's not development branches in the same way. All these branches are named like so: Sea Turtle, Diamondback, Electric, Fuerte, Groovy, Hydro, Indigo, Kinetic, Melodic. And if you know the ROS version system, then you know that these are all ROS versions. And every ROS version is a bit different. And that is why we have a branch for each of these. We also have a branch for the upcoming ROS 2. So a lot of the core programs are the same, which is why we can have these different branches for the different ROS versions. And it's just small changes in order to make it work with the different versions. So now you know a bit about how branching works, and now you can also work together with your mates on development branches and on feature branches without actually touching the nice master branch where you know everything works. And once you have software that works, you can just merge it into the master branch.